Topic 1, attributes of exponential functions. All right, so here's what we are doing today. It's exponential function, and what an exponential function is, right? It's basically a function or a graph that as the x values increase, your y values increase like rapidly. You see how it rapidly goes up? That's an exponential function, right? It's not like some steady curve. Exponential means like to increase very fastly, where the number starts being multiplied very fastly. So what are some attributes of an exponential function? So they're always going to have a y-intercept, and this is considered their initial value. So this right here is their initial value where it started, like at 1. So this is a y-intercept and initial value. And also, more importantly, there's always going to be an asymptote in play, meaning this right here is an example of an asymptote. Now, we talked about, I think, an asymptote once before, and what an asymptote is, it's a line or a curve that acts as a limit for another line, meaning, as you guys notice, this graph right here is going this way, and it increases, right? But as we're coming from this part in the end, what I want you to understand is that this dark blue line will never touch this light blue line. It will go closer and closer, but it'll never touch it. So this line right here acts as a limit, meaning it's basically like a barrier. This dark blue line will never pass this light blue line. So that's what an asymptote is, right? It's like a barrier. All right, so let's figure out my domain and range for both of these. I'm sorry, for this function. So your domain, let's think about it real quick. As my x values increase, right? So domain is all possible x values. So can I say this is the farthest x value to the left and this is the farthest x value to the right? I can't, right? It's going to go forever to the left and forever to the right. What is that also known as? All real numbers, right? So all real numbers. All right, cool. That's all real numbers. Now, what about my range? Does it go forever down and forever up? No, right? Because it goes forever up, which means it goes to positive infinity, but I know that it's going to be going towards 0, but it never really reaches 0. So I can say it's here, and it goes up to positive infinity. Now, what y value is this right here? This y value is 0, and it goes up to positive infinity, right? So what is that? So all my y values greater than 0. Not greater than or equal to, because it never really touches 0, so just greater than 0. And that's your domain and range. All right, so let's do some actual problems to see how this really affects the graph, right? We'll see how the way that it multiplies. So what we need to do is we're going to take this table value here. We're going to substitute these x values into this exponent, do the math, and then we'll graph it, and we'll figure out, I'll tell you whether it's increasing, decreasing in domain and range. So let's go ahead and start. So in order for me to fill out this table first, what I need to do is, remember, this is my x value, so I'm going to plug in my x value right here, right? So let's go ahead and do that real quick. So when I do that, it's actually 3 times 2 to the power of negative 3. And we can just plug this in my calculator real quick to see what I get. So let me do, so 3 times 2 to the parentheses, 3 times 2 to the power of a negative 3. Press enter. I get negative 0.375. So I have 375. And then, so that's how we got that answer there. So, sorry guys, kid was trying to come in this classroom. My bad. All right, so let's figure this out real quick. So all I did was plug in that x value into here, and then I got my y value. So the same applies here. So what I need to do is I need to figure out what is my y value when my x value is negative 2. So that's 3 times 2 with a negative 2 exponent, right? What is that right there? So I'll go up here and I'll just copy and paste it. And I'll go up here and I'll delete that 3 and I'll put a 2. So put a 2, that's a negative 2. And then it's a negative 0, well, that's a 0.75. Okay, I'm going to show you a different way in a minute. It's a lot faster, but this is one way, right? So we do it again. Let's fill in this table. It takes a little while right here. So I'm going to put a negative 1. So delete, put a 1. What do I get? 1.5. All right, we're almost done. Let's see. Go back up here, press enter. I want this to be a 0, so delete both of those. Put a 0, enter, 3. All right, go back up. 1. 6, and then go back up, and delete, and put a 2. All right, 12. All right, bam. So I've plugged it in. So let's see what we have now. Now all I need to do is graph, right? So let's start with -3 first. So -3, 0.375. That's like super close to this line. I'm going to just kind of guess and say it's there. So we have -2.75. That's kind of close to 1, which I would say was right there. -1 and 1.5, I would say is about right here. And we have 0.3, which is like right here. And we have 1.6, which is right here. And then we have 2.12, which is about right here. All right, so this is our graph for our exponential function. Let's go ahead and draw our line. So it never really crosses that x-axis. It never really crosses that. So don't draw it past it because it will never cross it. Because remember, this right here, this right here is my asymptote. This right here is my asymptote. It'll never cross that. So now I have my exponential table with a few values. I graphed it. Now let's figure out if it's increasing and decreasing. Here's how we figure out if it's increasing or decreasing. So let's think about this. If I start here, and as my x values increase, do my y values increase? Do my y values get higher? If they do, then that's an increasing graph, right? But as my x values increase, if my y values decrease, then that's a decreasing graph. So let's think about this, right? As I'm going from left to right, my y values are starting to go up. So that means this is an increasing graph. Oops. Whoa. Increasing. Bam. All right. What is my y-intercept? We already know where my y-intercept is. It's where my graph crosses my y-axis. Where is that at? That's right here. Here's my y-intercept. So what is that point? What is that point? So that's 0,3. Not bad. All right. What is my asymptote? Your asymptote is an equation, right? And your asymptote is whatever this line is here. This line is a horizontal line. It's a HOI, right? So it's a HOI, which means it is y equals whatever y value crosses. It is y equals 0. And then your domain, again, remember it's going forever left and forever to the right. So then your domain is all real numbers. And your range, how high and how low does it go? Well, we know it's never going to cross this 0 right here. So it goes to 0, but it never crosses it, and it goes all the way up. So my y values just must be greater than 0, right? Not equal to, but just greater. All right, so let's do a few more problems, and you guys will do the rest for homework. All right, let's do this one right here. Again, what we must do is, when you fill out this table, graph it, and then put it in whether it's increasing or decreasing. All right, now here's a new method that I'm going to show you how to do, and it's super easy, okay? So what you need to do is you need to get your calculator. All right, we have it out. And then we're going to actually graph it. So go into y equals, and let's type this out right here. Let's type all of this real quick. So 4 times parentheses alpha y equals, so I can get my fraction, 1 over 2. And I need to do an exponent of x. So you have to use this little, right under clear, you have to use that little exponent. So go there, and you need to type the letter x. So I'm gonna hit this x right here. Bam. Now that I've hit that, I can go ahead and graph it. So I'm gonna hit graph, and this is what it would look like. So I'm gonna compare my graph in a minute, but more importantly, the whole reason why I told you to do that was so we can figure out what are these numbers. Here's how. Right on the graph button, right above that, it says table. Let's go ahead and find my table. So hit the blue button, and then hit graph, and you should have your table. And it'll be so much easier to fill out. So if my x value is -2, what does my y value say? It's 16. Okay, -1, it's 8. 0 is 4. 1 is 2. 2 is 1, and 3 is 0.5. So it looks like it's decreasing, right? Looks like it's decreasing. We went from 16 to 0.5. All right, cool. Now let's go ahead and graph these points. So if I'm going to graph this, I have -2, 16. Oh, I can't even graph that, right? Because that's way down here. All right, -1, 8. -1, 8. I can do that. Bam. 0, 4. 0, oh, what was that? 0, 4. Was that -4? Maybe. Hold on, let me see. Nope. Oh, sorry guys, my bad. I messed up. Ooh, yeah, Mr. Salas, what are you doing? My bad. All right, negative 2, 16, I can graph. It's right up here. Bam. Negative 1, 8, I can. It's right here. Okay, cool. We have 0, 4, bam. 1, 2, bam. 2, 1, bam. And then 3.5, bam. All right, we trace it out because this is the actual graph. And it's never going to cross your or your x-axis, right? It'll never cross it. It'll try to get as close as it can as possible, but it'll never really touch it. That's why it's called an asymptote. Bam. All right, so that's what my graph looks like. Let's go ahead and figure out whether it's increasing or decreasing. Again, now remember we start here and we ask ourselves, as I go move my x values to the left, are my y values increasing or are they decreasing? Now notice, as if I go from here to here, as I start from here, we're starting really high and my graph starts to go lower and lower and lower and lower. That is a decreasing graph. So decreasing, D-C-R-E-A-S-I-N-G, decreasing. All right, cool. What's my y-intercept? We already know where my y-intercept is. It's right here. My y-intercept is a point, so 0, 4. My asymptote happens to be the same. It's whatever this equation is. We know this is a horizontal line, so it's a HOI. It's y equals whatever y value it's crossing, which is 0. My domain is all real numbers. And my range, how high and how low. Well, this seems the lowest that it will go, and it never touches 0, and it goes all the way to positive infinity. So it's going to be y values must be greater than 0. Bam. All right. So this is the difference between an increasing graph and a decreasing graph. Now, this right here is your guys' homework. It will be on Canvas. You won't do all the problems, but it'll be a few of these problems. And so let's go ahead and I think you guys can do this all yourself. Good job. This part right here, we're not going to do. I'll briefly explain it, but we're not going to do. I'm just going to only explain one. All right, so let's think about this real quick. We'll just do it real quickly. So here we go. It says, in a Pay It Forward, Haley Joel Osment's character demonstrated the idea that on the first day, he does a good deed for 3 people. Then the second day, those 3 people will perform a good deeds for 3 different people. And the process continues. So we got to fill out this chart without actually knowing like that formula they gave us. So how do we do that? Now here's how. All right, so let's think about this. I'm up here. All right, so here's this dude right here. Right, here's this dude, and he's doing a good deed for 3 different people, right? So here's this person doing, here are the 3 people he does the good deeds for, right? Bam. All right, cool. Now, each one of these people do 3 more good deeds to 3 different people. So like this person right here is going to do 3 different good deeds, right, for the 3 different people. Bam, bam, bam. Okay, and then this person right here also does, good deeds for 3 different people. And then this person over here does another good 3, right? So we got to find the relationship that's actually happening. Bam. It's like doing some karate. Hiya, hiya. Ooh, kick. All right, bam. So let's figure out what's happening. So it says on day 1, right, this person does a good deed. And how many deeds are done for 3 people? All right, cool. So on day 2, how many good deeds were done, right? Let's think about this. This is day 1 right here. Whoa. This is day 1 right here. Right, 3 good deeds were done. On day 2, this is day 2. This is the next amount of good deeds that were done. We did how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 good deeds were done on day 2. And it just keeps going on. And it's actually multiplying. So what number did I have to multiply for 3 to get to 9 times 3? So on day 3, we'll have 27, right? Because that's times 3. And on day 4, you multiply this number times 3 and keep going on. And that's how that works, and you graph it. So this is why it's called exponential, because this graph, the way it would look, it would just curve so high, so fast, because it's an exponential graph. All right, so that concludes your guys' notes for today. Again, your homework will be these problems. They'll be on Canvas for you to submit your answers. Have a good day.